This is a very quick summary of our shot timer products. We have three. This is the basic unit with the BNC connector. This is a unit that is used for a proximity shot timer where you hold it next to a cable aligned with this stripe and it will give you a shot time. Here's a shot time with a BNC connector and a USB connector used for data capture. Now regarding the specifications, the display range is from 0 to 9.99 seconds. The accuracy is better than 1%. The resolution on these units is 10 milliseconds, but we also make a 1 millisecond resolution unit. Minimum voltage pickup is 5 millivolts. We'll be operating here at about 10 millivolts. The maximum input voltage would be 20 volts. And they have an IP rating of IP65. We want to run a performance and accuracy test for our shot timer, and this will be the basic model with the BNC connector. And our test setup consists of a Magpie prototype model in an MP1000 housing. And then we have a Panasonic timer controller, and also we have a voltmeter that is monitoring the voltage of the shot, and let's see, it should be around 10 millivolts. Okay, let's make that a little longer so we can actually see it. So that's reading about 9 millivolts there. So it's slightly under 10 millivolts input. And so that's our test setup. And we have our shot right there. And the shot is connected to our shot timer through those wires there. And so what we want to do is to capture this time and the time of our shot timer. So our shot timer is already connected, and so we'll clear it. We're at 2.5 seconds there, and so we'll shoot it. Okay, 2.5. Okay, let's do it again. 2.5. And 2.5. Okay, let's go down. .27 seconds. So it's very fast. And with this unit, it will be plus or minus 1 digit, and that's because of the carryover factor. If it's actually 0.273, it should round down to 0.27. If it's 0.275 or higher, it'll round up to 0.28. So let's stretch it out a little further. Let's go to 6.6 seconds. First it had to clear and reset itself. So now, .67. Let's go to 5 seconds. Five seconds exactly. Plus or minus 1 digit. 5 seconds exactly on the meter. 5:01 here. 5.01. Plus or minus 1 digit, it's in spec. This will clear it if you want to start from 0. Otherwise, it has auto update. And you can clear it from here, or you can. Or you can, this is set at 1 second, or you can allow it to just auto update. And your start and stop does not are disabled while it's in this mode, so you can't clear it here. But if you cleared it here, now these work. There you go. 4 AA batteries. A detector showing that it's captured the shot and its timing. It has nameplate and calibration sticker. So that's the end for the basic shot timer operation. Thank you. Okay, next we want to look at our other shot timer, which is a proximity shot timer, which has nothing to connect to. It's just works by sensing the magnetic field, and just being close to the magnetic field is enough to cause it to begin counting. It'll count as low as lower than 100 amperes of output current, and it can go as high as 20,000 amperes. So 4 AA batteries, and much of the features as the BNC type, except this one there's no wire to connect. So let's test this one, and we can do that by putting this cable here. So this should be parallel. This stripe should be parallel to the cable. Okay. We're at 1 second. 101. Let's clear it. $101. $101. Let's clear it. Okay. Let's go for 5 seconds. $501. We will tweak this down and you'll see that it'll be exact. We're just about 8.3 milliseconds longer than we need to be. That's why it keeps rounding off to the higher number. Okay, next we want to review and just look at the operation of our data capture model. Here's your BNC connector and your USB connector fittings on top. Okay. We have the same setup, almost 10 millivolts here on output, taking it from our shot, a controller timer in the front, and we have our data capture shot timer. All the basic features as the other 2 shot timers, except this one can capture your data via the USB. So first we'll see that we're at 0. We're at 1.93 here. I don't think I need to show you that, but I will anyway. You can see that, that's 1.93. Okay. So let's operate this and see what happens. Okay. 1.93 plus or minus. And as you can see, that this is also displayed on the computer. I've moved the shot timer next to the computer. And okay. Now let's shoot it. Here we go again. You might be able to see this too. See that? 1.93, 1.93. So there you go. So with this, also when we put this together with our shot kit, we'll have shot duration time, whatever it is, in seconds, and then we'll have current output, and it'll be in amperes. And from that, this data is going to be populated into a spreadsheet that'll look something like this. And the red numbers are the numbers that will be generated, and then you could put in your operator number, operator ID, date, time, and those red numbers are actual numbers from our devices. And we can also get watt hours. And you can also check to make sure that your operators are being productive.